Hi, this is Rajesh Kumar. I am going to present a paper on Trustzone system security by ARM processor. In this project, I am going to explain what is Trustzone software and the security level of Trustzone software and architecture and software configurations in Trustzone software and the Trustzone ready program and also the architecture of Trustzone and trusted execution environment and also the advantages of Trustzone. In this Trustzone technology is a system-wide approach to provide the security on high-performance computing platform. It is mainly used to provide the security for rich OS. This Trustzone technology is used in huge array of applications, including security payment, DRM, that is digital rights management, and web-based services, and also the enterprise services. First, what is security payment? Security payment is nothing but it involves the bank transaction and credit card transaction and also the mobile payment. For this secure payment, we are implementing the Trustzone technology to enhance the security. And next one is DRM. It is nothing but digital rights management. It is an access control technology which is used by the hardware manufacturer, publishers, and also the copyright holders. They are using the digital contents and also the digital devices after the sales are purchased. And in this digital rights management, we are implementing the Trustzone to enhance the security. This digital rights management includes, this is the diagram for digital rights management. This is applications of OS. This is rich OS, Trustlet, and MobiCore. This is the trusted environment, which provide the security for the applications like device security, mobile services, mobile transaction services, database, and also the enterprise services. This is connected to the internet, and this digital rights management is provide the applications like this, and we are implementing the Trustzone technology for these applications. And next one is web-based services. Web-based services is nothing but it is an online services which includes the online services like online ticket booking and online services and also the online payment systems. In this also we are implementing the Trustzone technology to increase the security. And the next one is enterprise services. Enterprise services is used to increase the business integrity, and it is also used to build the SOA, that is service oriented architecture. And these enterprise services includes many applications same as the DRM. This is the enterprise service bus, which includes database, security applications, packaged application, legacy applications, and also the business partners. This is the services included with this enterprise services. And where the Trustzone technology is implemented, this Trustzone technology is implemented within the microprocessor. Microprocessor is nothing but it is an integrated circuit which includes all functions about the CPU, and this Trustzone technology allows the on-chip and off-chip memory, and also the peripherals to be protected. What is on-chip memory? On-chip memory is nothing but it is a default memory which is in the microprocessor, and off-chip memory is nothing but which is an external memory added to the microprocessor, and the peripherals are nothing but it is an external component devices that is added to the system, that is display, keyboard, mouse, and crypto blocks. Crypto blocks are used in the cryptography encryption, that is the original text is converted into the system understandable block, that is which is converted by the block, that block is called as crypto blocks by the use of the security key. And this Trustzone is a set of security extensions added to the ARM v6 processor and also the greater version of ARM v6 processor, such as extension of these ARM v6 processors are ARM 11 and Cortex series, that is Cortex A8, Cortex A9, and also the Cortex A15. What is ARM processor? ARM processor is nothing but advanced RISC machine. In this, RISC is nothing but reduced instruction set computer. In this instruction set is part of computer architecture which is related to the program and which includes the addressing modes, memory, and these instruction sets are mainly two types, that is reduced instruction set and complex instruction set. Reduced instruction set is nothing but less than 100 instruction set is called as reduced instruction set, and more than 100 instruction sets are called as complex instruction set. This ARM processor widely uses the 32-bit instruction set. This is about the ARM processor and the location of Trustzone technology. Trustzone is the chip level program which is programmed into the hardware, which is used to enabling the protection of memory and the peripherals, and it avoids the security threat caused by the proprietary and non-portable solutions outside the code. And next one is application modes of Trustzone. There are three application modes in Trustzone, that is normal, system, monitor. What is normal application mode? Normal application mode is nothing but Trustzone technology is implemented within the user space applications, and system application mode is nothing but the Trustzone technology is implemented within the kernel. Kernel is nothing but it is the central module of the OS. All the functions of central processing unit is functioned by this kernel, and when the system starts, the kernel will be started first. And next application mode is monitor. Monitor application mode is nothing but the Trustzone technology is implemented within the trusted kernel. In this trusted kernel is nothing but the secure OS contains the kernel is called as trusted kernel. And what is Trustzone software? Trustzone software provides the minimal secure kernel which can be run in parallel with the more fully featured high-level OS such as Linux, Android on the same core. This is the Trustzone software which provides the minimal secure kernel, which is nothing but trusted kernel, and which can be run in parallel with this is the normal and this is the secure. this is parallelly run in the same core, that is same platform. And this Trustzone software is provides the drivers for the rich and normal OS, which is used to communicate between the secure OS. This is the driver which is provided by the Trustzone software, which is used to communicate between the normal and also the secure OS. And the example for this drivers is SMC, that is secure monitor call, which is the one of the driver provided by the Trustzone software. And next is this Trustzone software uses ARM Trustzone security extensions, which is used to completely protect the secure OS and any secure peripherals from the code running in the normal world. That is, if an attacker, this is the normal, this is the secure, both are running in the same code. By the use of secure channel, they are communicating each other. When the attacker attacks this normal OS, they can find the full root of this normal OS. Even he cannot able to attack, even he cannot able to access the secure OS. This is the specification of this Trustzone software. And the next one is security level of Trustzone software. There are mainly 3 security levels in Trustzone software, that is low level security features, and Trustzone software with security services, and next one is security client. What is low level security feature? Low level security feature contains the crypto accelerators and on-chip key. Crypto accelerator is a coprocessor which is used in the encryption. In this, the plain text is converted into some other system understandable codes by the use of the system on-chip key, and also which provide the security feature of security execution mode and firewalls. And next one is secure memories. In this, the valuable data are stored. The unknown person cannot able to identify the data. And next one is Trustzone software with security services, which is nothing but trusted execution environment which can concentrate on security sensitive functions, and which leverages the low level hardware security features, and also which provide the uniform interoperable standard based APIs. And these both are combined together, and which is used to communicate between the secure client by the use of client server module. Secure client is nothing but it is a rich OS, which is an operating system, and also the applications which is running on the operating system, which have the low security sensitive functions. Next one is architecture of Trustzone. Architecture mainly contains normal world, OS, secure channel, and platform which is able to run on the both normal and secure. In normal world, we are having the security demanding applications, that is user defined applications, and secure API. API is nothing but application programming interface, which is used to communicate between the user and applications, and which is mainly used for security purpose, and which provides the secure services for the user defined applications. And next one is secure service stubs. Stubs are nothing but client side proxy, which is used to marshalling the data. Marshalling is nothing but conversion of Java code into network oriented string. This stub also used for the security purpose, which is running on the OS, which is defined by the user applications. And next one is Trustzone API. Trustzone API is mainly used to provide the security which is running on the normal world OS applications. And next one is Trustzone software driver. Trustzone software driver is nothing but which is a software which is used to which is act as an interface between the hardware and the OS. And next one is OS, that is operating system, which is used to communicate between the user and system. And next one is secure channel, which is before that we will see the secure world. In secure world, we are having the secure services and interpreted secure services, and we are implementing the Trustzone logic in this secure world only. In this, we are implementing the security module technology, that is Trustzone software. After that, the hardware abstraction layer API is there, that is nothing but HEAL API, which is used to communicate between the hardware and the user applications, and we are implementing the hardware abstraction layer here, and then the both normal world OS and secure world OS are connected to the secure channel. This secure channel is running based on the client server mechanism, and these both normal and secure worlds are run on the same platform. This is the architecture about the Trustzone. And next one is how to create the Trustzone execution environment. There are three main steps to create the Trustzone execution environment. The main steps are: define the secure hardware architecture, and the second one is implement in silicon system on chip. Third one is combine the SOC with trusted OS. First, we will see the steps briefly. The first, we are separating the two domains, that is normal and secure. After that, we are extending the secure services across the system peripherals such as display, keyboard, memory and clock. After that, once we define the secure and normal, after that we are implementing the system on chip, which is used to enforce the secure and normal separation physically. In this system on chip is integrated circuit, which is used to integrate the system components, and after that the implementation of SOC is normal, secure. After that, once we implement the SOC, we are combine the SOC with trusted OS. This is the SOC. In this, we are combining the normal and secure. This is nothing but the result of these three steps gives trusted execution environment, which is used to ready to develop and deploy the user-defined applications, which is the trusted services. And configuration, software configurations of Trustzone is three main software configurations in this Trustzone. One is monoprocessor configuration with hardware firewall execution environment. Second one is monoprocessor configuration with hardware firewall execution environment. Software firewall execution environment. Third one is biprocessor configuration with any physical link. Let me see one by one. First one is monoprocessor configuration with hardware firewall execution environment, which is nothing but it is an architecture, same architecture of the Trustzone. In this, we are having same as a normal world and also the secure world. Both are running the same platform. These both are both normal and secure worlds are connected together by the use of this secure channel. In this, secure channel is secure channel is hardware. This firewall, this is called as monoprocessor configuration with hardware firewall execution environment. And second one is monoprocessor configuration with software firewall execution environment. In this, this is the same as Trustzone software, which contains the security demanding applications and Trustzone API, as well as the security services and secure module framework in the secure world. In this, both normal and secure are running on the same platform, and this monoprocessor configuration with software firewall execution environment, the OS are same for the both normal and secure. In this, the firewall is inbuilt in the OS, that is which is in this the software firewall execution. The secure channel is software, so that it is called as monoprocessor configuration with secure firewall execution environment. Next one is biprocessor configuration with any physical link. In this, these above both the hardware and software firewall execution environment, the normal and secure world OSs are run in the same platform, but in this biprocessor configuration with any physical link, the normal world OS is running in the separate platform and the secure world OS is running in the separate platform. In this, the secure channel may be the hardware or software. This is the multi-core support by the Trustzone. The Trustzone software supports multi-core, that is, the normal world and secure world OS can share the platform, or it can able to run separately in the platform, which is called as multi-core platform. And all the versions of ARM processor can also be support these multi-core. It can be able to run in the same platform, or it can be able to run in the different platform. And how the security starts from the boot. When we on the system, first boot ROM will run, then secure perimeter. Next one is secure services. First, when we on the system, the boot ROM will run. Boot ROM is nothing but it is a memory chip which is used to start the workstation from the server. And next one is the perimeter. Secure perimeter will start. After that, the secure services will run. In these secure services, we have the normal and secure OS, and also the applications running in the rich OS. This is the security provided by the Trustzone software. This is the specialty of Trustzone software, so that we are using the Trustzone, which is used to enhance the security. And the next one is Trustzone Ready program. Trustzone Ready program. Trustzone Ready program is defined by desired services, that is, the services are designed by the market requirements and the industry factors. Once the services is desired, we can implement the SOC platform. The implementation of SOC platform depends upon the security design blueprints and trusted execution environment integration and interoperability standard APIs. Once the system on chip platform is implemented, after that we are assuring that implementation of system on chip platform by use of the SOC checklist. Once this assured, after that the Trustzone security system by ARM will give the industry certification, which is a Netflix global platform. Next one is ARM trusted based system architecture. In this architecture, we are having the three main blocks, that is the core execution environment, system anchors, and system integrity. In this under the core execution environment, we have the boot ROM, on-chip memory, and off-chip memory. And under the security anchors, we have keystroke, random number generation, and counters, and also the timers. And under the system integrity, we have debug, test interface, and power control. Apart from this, this is the SOC architecture. In this, we are having the multiple number of integrated circuits. In that, there are many trusted blocks, that is trusted RAM, physical layer, and also the DMC. Next, trusted region mapping, and trusted configuration registers, and trusted SRAM, and also the secure peripherals and configurable secure peripherals, and trusted clock, system control, and power subsystem, that is SCP, and also the other trusted CPU and masters. And also we have the trusted capabilities processors, that is processor cluster and co-site debug subsystems. And also there is a main two blocks, that is switchable between the trusted and normal world, that is display controller and also the GPIO. We will see one by one briefly. The blocks are first one is GPU, that is a general processing unit, which is also called as visual processing unit, which is used to accelerate the memory for image buffer. And next one is processor cluster, which has the trusted capabilities. And processor cluster is nothing but which is the combination of two or more processors. In this processor cluster, we have processors ARM V7A and GIC and cache memory that L1 and L2. First, ARM processor as before that we saw that ARM processor, that is advanced RISC machine, which contains the 32-bit instruction set computer architecture, and the next one is GIC, that is generic interrupt controller, which is used to support the interrupt from the trusted execution environment, that is interrupt which is used to support for the normal OS interrupt and also the secure OS interrupt. And in this processor cluster itself, we have the cache memory, that is L1 and L2. Next one is core side debug subsystem. In this core side debug subsystem, only the responsible for the debug process. This is used to the SOC developers can trace and debug the next other IP systems. And the next one is display controller, which is the input and output block. And this display controller is used to control the output from the input device to be displayed in this output device. And next one is trusted clock. Trusted clock is used to measure the time intervals of the process, and which is comes under the trusted blocks, and also trusted test manufacturer. Trusted test manufacturer provides the test interface, which is used to provide the test cases which is used for testing in the SOC platform, and which also contains the other trusted CPU and masters, and power system control and power subsystem, that is SCP, is nothing but it is responsible for the power control which is consumed by this SOC architecture. And also these non-trusted integrated circuit and trusted integrated circuit are connected through this interconnect, and this configuration register also comes under this trusted block. And if we see the trusted blocks within this SOC architecture. First, trusted region mapping. This trusted region mapping is used for routing purpose. And the next one is trusted configuration registers. This trusted configuration register is inbuilt within the trusted platform module, which is a 25-digit registers, which is responsible for developing the trusted platform module. And next is trusted SRAM. SRAM is nothing but static random access memory, which is used to store the data as static manner. And trusted boot ROM. Boot ROM is nothing but which is a memory chip which is used to start the workstation from the server or from the remote. And the next one is scratch RAM, which is comes under this trusted block, which is also used to store the data in the static manner in this SOC. And the next one is trusted region mapping. As I said before, the non-trusted block also we are having the trusted region mapping, and heavy trusted, I mean high security trusted blocks also we are having this trusted region mapping. And flash control. Flash control is used to control the flash memory, and PHY is nothing but which is the physical layer of the OSI model, which is used to communicate between the memory and memory control and also the trusted RAM, which is act as an interface in this SOC. And the next one is non-secure peripherals. Non-secure peripherals are in this SOC such as timers, counters, RTC and MHU. First, timers. Timers in this non-secure peripherals are used to measure the time intervals of the process and some functions involved in this SOC. And next one is counters. Counters are used to store the time intervals of the processes as it is measured in this timer. And the next one is RTC. RT is nothing but real-time clock. It is also used to measure the time intervals of these processes. And MHU is nothing but message handler unit. This MHU is used to handle the request message and the response message in this SOC platform. And next is OTP, that is one-time programming, which is comes under the trusted blocks, and which is also combined with this NV converter. And next is random number generation, which is used to generate the random numbers, which is responsible for the some of the specific applications in this SOC. And the next one is real-time clock, that is RTC, which is also to measure the time intervals of the process which is run in these trusted blocks. And next one is configurable secure peripherals. These OTP, NV converter, random number generation, and real-time clocks, and WD timer is built in these secure peripherals. And next is configurable secure peripherals, which is that GPIO, that is general purpose input output, which is used to manage the input and output which is runs in this SOC platform. And this is the input device which is externally added to this SOC. In this, by the use of this input device, we are giving the trusted input to the SOC. That input is processed by the use of these trusted and non-trusted blocks in this SOC with the use of configuration registers. After that, the processed output is displayed in this externally added display by the use of the display control. And next one is DMC, that is dynamic memory control, which is used to control the CPU memory, and also which is used to allocate the memory for the process. And the next one is PHY. As I said before, in the trusted block also we are having the PHY layer, and in this PHY is nothing but physical layer of OSI model, which is act as an interface between the DMC and DDR. And next is trusted SRAM. Trusted SRAM is nothing but which is a high secured RAM. In this SRAM is called as static random access memory. This is used to store the data in static manner. And next one is DDR, that is double data rate, which is used to store the data in the fast, and in this double data rate the RAM memory is robust. And the next one is trusted RAM. In this trusted RAM is nothing but off-chip memory, which is externally added to this SOC, which is for increase the process memory. And the next one is flash. Flash is nothing but it is a non-volatile memory which is used to store the data, and electrically we can delete or we can alter the data by in this SOC. And the next one is firmware. Firmware is nothing but it is an predetermined memory and also the programming code. It is a combination of that memory and code which is also used to store the data. Example for firmware is embedded systems. And this is all about the trusted based system architecture. This trusted based system architecture is nothing but it is an SOC, as I said before. SOC is combination of integrated circuits, and these are all the components which is comes under this ARM trusted based system architecture. Next one is trusted platform security. Under the trusted platform security, we have main two components, that is trusted execution environment and trusted platform module. First, we see trusted execution environment, that is TEE. Next one is TPM. First, we will see that TEE. TEE is nothing but it is a secured environment, that is the program can be able to run in the core that secure manner. The TEE is a protected or secure execution of critical applications in virtualized environment, which is used to execute the program in secure manner. And this trusted execution environment is safe and secure boot, and it ensures all system software components are in a known and trusted state before launching. And this trusted execution environment support multi-services and multi-client services, which is also used to run in the multi-core services platform. This is the mainly used to provide the security for the application which is running on the trusted environment and also the HOS. And standard bodies of this trusted execution environment are ARM Trustzone, Intel TXT, AMD SEE, and HP Visa Masters. First, ARM Trustzone. ARM Trustzone nothing is used to provide the security for the software and also the hardware, which is more secure and more reliable, and it is used to secure the valuable content. Next one is Intel TXT. Intel TXT is nothing but it is a product of Intel, and ARM and Intel processors are combined to create this Intel TXT, which is developed based on the cloud services. And this Intel TXT is nothing but Intel Trusted Execution Technology. This is called Intel TXT. The Intel IT services and the ARM processor are combined to create with the cloud technology. Cloud computing is called Intel TXT. And the next one is AMD SEE. AMD SEE is nothing but it is an AMD secure execution environment, which is also the AMD processor also combined to ARM with create this SEE. And other standard bodies like HP, Visa, Mastercard also combined with this ARM processor. And next one is Global Platform Trusted Execution Environment API. This Global Platform Trusted Execution Environment API has defined three aspects, that is Trusted Execution Environment, Client API specification, second one is Trusted Execution Environment, Internal API specification, third one is Trusted Execution Environment, System Architecture. Let me see first Trusted Execution Environment, Client API. In this Trusted Execution Environment, Client API specification, which is very similar to the ARM Trustzone API, the applications running in normal OS can be ported from the Trustzone API to Client API with a simple wrappers. For example, this is the normal and secure, both are running in the same platform, which is both are communicated by the use of secure channel. In this, the Trustzone API is switchable between the normal and also the secure. As the same, this Trusted Execution Environment Client API also which is portable between the normal and secure. Next one is TEE, Internal API specification, that is Trusted Execution Environment Internal API specification, which defines the secure OS implementation and which enables the easier porting of secure tasks from the one vendor to another vendor, which is one OS to another OS. Third one is Trusted Execution Environment System Architecture. In this Trusted Execution Environment System Architecture, we define all the software architectures. And next one is Trusted Platform Module. Trusted Platform Module involves these three functions, that is remote attestation, binding, and also the sealing. What is remote attestation? Remote attestation is the process that is the normal OS and secure OS are running in the same code. At the time, the hacker can be able to hack the full of normal OS, and he cannot able to hack this secure OS. So by the use of this remote attestation, this secure this TPM remote attestation function can be done. And next one is binding. Binding is nothing but when the chip is manufactured, the RSA key encryption process is bound within the processor by the use of the at the chip level itself, which is very secure. This is called as a binding function. In this, the cryptography encryption, RSA key encryption is inbuilt within this processor is called binding. And next one is sealing. Sealing is nothing but in the trusted execution environment, the third party cannot able to access the secure services is called as sealing. And the next one is GP compliance and certification. That is Global Platform Compliance and Certification. There are two main processes in this GP compliance and certification. That is Global Platform Devices Committee, and next one is Certification Working Group. These two committees are provide the global platform certification, and first one is Global Platform Devices Committee. In this, the normal world and secure world APIs are published. After that, the secure world trusted API under the public review. And second one is Certification Working Group. In this, once the software is licensed, after that we can reuse the GP composite certification process, and they are certifying at the chip level and finally checking at the device level, and after that we defining the security targets. Next, global demand, that is applications of these trust zones are which is used in content protection, payment service, enterprise, and also the commerce. In content protection, by the use of cloud-based services, the digital rights with the use of the digital rights management, we are protecting the valuable contents on the payment service and bank. In the payment services and bank also, we are using the Trustzone to secure to enhance the secure. And in enterprise, we are using this Trustzone for anti-malware. And commerce applications like vouchers, location-based services, also we are using this Trustzone. And other applications of this Trustzone are headless gateway, mobile payment, DRM. Headless gateway. In headless gateway, the Trustzone is used for protect the routing information and also the network configuration. In mobile payment, we are using the Trustzone which is running on the Android. That is the latest Google Wallet is used with this ARM for the mobile payment application. And DRM, in DRM we are using the content protection, and in this the set-top boxes also, set-top boxes and media players and also the mobiles also comes under this DRM. These are all the other applications of Trustzone. And next, Microsoft demonstrated Trusted Platform Module 2.0 implemented using the Trustzone. And next is how the Trustzone will work. For a mobile payment or banking, once the by the use of the external computer peripherals, that is input device, by the use of the input device we are giving the input. After that, it is processed by this system on chip with the secure aware component. After that, this input is processed through the ARM processor with the Trustzone security extensions. After that, through the Trustlet, the input is passed through the service authority. Once the user input is authenticated, the service will be declined or provided as per the user input. In this, Trustlet is nothing but which is used to collect and distribute the network databases and also the program codes. And this the trusted pin entry path, there are 3 steps, that is, as I said before, the trusted hardware peripherals input, that is this user input, and which is processed through the trusted software, and after the trusted software process, which is sent to the authentication service authority. Once the service authority, the user input is authenticated, the service will be provided or declined as per the user input. And this Trustzone also used with the Android applications, that is QEMU and hypervisor. Fiasco microkernel and L4 runtime environment, L4 Android. And in this Trustzone, for mobile Android, we are using the MobiCore technology. MobiCore is nothing but which is used for which is used for mobile services, which is runs on the mobile phones and also the other mobile devices. Smartphone and also the other mobile device. They are in need of the security, so that we are providing this MobiCore, which is used by the mobile manufacturer and also the network providers. For this MobiCore, which is runs on the mobile TE platform, by the use of this component, the mobile security can be implemented. First one is QEMU, that is quick emulator, which is used to provide the security for the Android applications, and hypervisor is the interface between the quick emulator and also the other applications running on the OS. And Fiasco microkernel. Fiasco microkernel is nothing but which is also Android security provider, which is used to provide the security in the smartphones and also the tablet. Next one is L4 runtime environment, which is developed by the L4 Linux, which is combined with the Android. And by the use of this ARM Trustzone, we are creating this L4 runtime environment so that the security can be enhanced. Next one is L4 Android, with the L4 which is derived from the L4 Linux. This L4 Linux and Android and Trustzone is combined to create this L4 Android, which is more security than the other OS. And next one is M-sealed. The M-sealed application is nothing but which is implemented in the ARM architecture. In this, the normal and secure world OS are there, which is used to connect it between this by the use of the secure channel, which is running in the same core. Instead of this HAL API, we are implementing the mobile shield API, and after that we are implementing the M-shield implementation, so that which is ready to use for the mobile applications. And benefits of this Trustzone are which is quicker to market with right product and reduced cost, because which is one time cost. At the manufacturing time only we are using the car, and it is increased sale, which provides the standard API for security software and hardware security. Thank you.